Hello everyone, this is Tom from TutorBros. Today we're going to learn how to solve quadratic equations by factoring. Now bear in mind that not all quadratic equations can be solved this way, only ones that have an easily factorable trinomial. And I will spare you the suspense and let you know that all of these equations here do have easily factorable trinomials. So the first step in this process is to ensure that we move all of our terms over to one side of the equation and then set it equal to 0. Then we factor the resulting trinomial into two binomials and employ what's called the zero product property. And to see how that works, let's do these example problems together. So we'll start with number 1, and I will rewrite it down here. So we'll do x squared minus 3x plus 2 is equal to 0. Now remember that the first step would be to move all of our terms to one side of the equation and set it equal to 0. But that's already been done for us here, so we don't have to worry about that. The next thing we want to do is factor the trinomial into two binomials. So we'll write our parentheses down here. We know that the first term in each of the binomials is going to be x, because the first term in the trinomial is x squared. And we know that both of the signs in the binomials are going to be negative, because the constant term is positive. So that tells us that the signs are the same. And then the middle term here in the trinomial is negative, so that's what tells us that both signs in the binomial are going to be negative. Then we have to say, well, what are pairs of factors of 2 that add up to get negative 3? And there's actually only one pair of factors that multiplies to get 2 at all. So that would be 1 and 2. And since we know that the signs in the binomials are negative, we don't have to worry about combining positives and negatives and whatnot. So it's just going to be x minus 1 times x minus 2, and that's still equal to 0. So all we did was just factor the trinomial into two binomials. Now we employ what's called the zero product property, which says that if we're multiplying things together and the product is equal to 0, then at least one of the factors has to be equal to 0. And if we think about that for a moment and just reflect on it, it just kind of makes sense to us. But just to reiterate, if we're multiplying things together, product is 0, one of the factors, at least one of the factors, has to be equal to 0. So what I can do here is set each of the factors, each of the binomials that is, equal to 0. So x minus 1 could be 0, and x minus 2 could be 0. And then I just solve for x in each of these equations. So if x minus 1 is 0, then x is equal to 1. And if x minus 2 is 0, then x is equal to 2. And that's all there is to it. So these would be the solutions to the quadratic equation in number 1. And I'll write them up here. So x is equal to 1 and to 2. And that's it. Alrighty, so done 1. Let's try another one together. All right, we'll do number 2. So it's x squared plus 4x is equal to 21. Now remember that the first step would be to move all of our terms to one side of the equation and set it equal to 0. We didn't have to do that in the first one. It was already done for us. But in number 2, we do have to do that step ourselves. Easiest way to do that would just be to subtract 21 on both sides of the equation. So then the resulting equation would be x squared plus 4x minus 21 is equal to 0. And then we factor the trinomial into two binomials. So we know that's going to be x and x. And then we know that the signs are going to be opposite. One will be positive and another will be negative. We know that because the constant term is a minus 21. Then we have to ask ourselves, well, what pairs of factors multiply to get negative 21 that add up to get positive 4? So the positive factor is going to be the bigger one, and we know that because the middle term in the trinomial is positive. I can only think of one pair that works here. I think it's going to be positive 7 and negative 3. So it's going to be x plus 7 and x minus 3. And that's because 7 times negative 3 is negative 21, and 7 plus negative 3, or minus 3, would be equal to positive 4. Alrighty, and then we just set that equal to 0. and then we set each of the factors equal to 0 in order to solve for x. So we can say that x plus 7 is 0, and x minus 3 is 0. And then we just solve for x. So x would be minus 7, negative 7, and x would also be equal to 3. These would be the two solutions for number 2. All right, and I'll copy them up here. So x equals negative 7 and 3. Alrighty, 2 down, 1 to go. All right, let's erase that. Okay, now let's try number 3. So we have 2x squared equals 11x minus 5. And again, first step, just move all of the terms in the equation to one side and set it equal to 0. So I'm going to subtract 11x minus 5 on both sides. So the equation would now be 2x squared minus 11x plus 5 equals 0. Now you'll notice that in number 3, the coefficient of the squared term is 2, which can make things a little bit more difficult, but there are different methods for factoring a trinomial where the leading coefficient is not equal to 1. We could always use the a times c method, but the numbers here I think are small enough that we can maybe just do a little bit of guess and test in order to find the two binomials. So I'm going to sorry about that. Just going to do a little guess and test here. So we'll break this up into two binomials. Now, since the first term in the trinomial was 2x squared, the only two possible first terms in the binomials could be 2x and x. So I know that one of them's 2x, one of them's x. So what else can we determine? Well, the constant term is 5. So we can say that the second term in each of these binomials is going to be 1 and 5. That's the only pair of factors for 5. So it's just a matter of figuring out in which binomial each of those numbers goes. Now, the middle term in the trinomial is negative 11x. So I think at some point we're going to have to multiply the 2x and the 5 together. So I think the 5 is going to be over here, and then the 1 will be here. And then the 5 is positive, middle term is negative, so the middle, or the signs of the binomial is probably going to be both minus. And let's just check that real quick by doing the FOIL method. So we have 2x squared minus 10x minus x plus 5, and that's 2x squared minus 11x plus 5. So that checks out. So we did do a little bit of guess and test, and we did determine that the two factors, or the two binomials, are 2x minus 1 and x minus 5. Alrighty. And then we set that equal to 0. And then we set each of the individual factors equal to 0 as well. So we can do, say, 2x minus 1 equals 0, and x minus 5 equals 0. And then we solve for x in both equations. X in the first equation would be equal to 1/2, and the second equation, x would be equal to 5. So these would be the solutions to the third quadratic equation. So we'll write them up here. X equals 1/2 and 5.